Yeah, in the last lecture we had seen secure socket layer, okay, SSL and its various phases. So in this particular lecture, we are going to see in detail what exactly is a secure shell. We had started with secure shell in the last lecture, but due to shortage of time, I couldn't finish it up yesterday. So we'll go in much detail what exactly is secure shell, how we can provide security to a particular communication link from a client to a server, and then we will see what exactly are the various ways by which we can safeguard our systems by following certain rules of privacy. Obviously, if we make sure that our privacy is safe, then what we can do is we can safeguard our entire systems, our entire networks. Okay. Finally, towards the end of this lecture, we are going to see what are the various attacks that take place on web browsers. Because as you know, the web browsers are the entry and exit point of any network. We can't access any network without any GUI. We can do so with the help of console, but that is a really tricky thing. For us, the end users who are not having much more technical knowledge, for them GUI is must. We can do it with the help of console, but the people who are not technically sound, they cannot access the network without any browser. So we have to make sure that the product which we are making for the common masses, that should be secure enough, because at the end of the day, as computer engineers, as software engineers, you are going to develop certain things, right? And it's your responsibility to make sure that those software solutions or software systems which you develop are safe enough for people to carry out their day-to-day activities. So at the end, we're going to learn what are the various attacks on web browsers and how we can safeguard our systems against those attacks. Okay. So kindly let me know if so far there is any network issue or any network lag, or else I can continue. So what exactly is a secure shell? I will just open this slide once again for you. I had covered these topics yesterday, but still revise it once again. So network protocol, this is basically secure shell is a network protocol which is used for securing the data flow between a client and a server. So secure shell is basically, as I had explained yesterday, it's basically like a virtual tunnel between the client and the server, okay, using which the client can securely create a connection with the server. Clear? So what exactly happens is it is basically a network protocol which is used for securing the data flow between a client and a server. It is quite similar to SSL. SSL was secured. What was SSL? Kindly let me know.
Secure socket
Correct.
layer.
It's secure socket layer, and this particular concept is secure shell. So basically, we are creating a shell. Shell is nothing but, as we all know, shell protects the things which are present inside. Similarly, over here, a secure shell is nothing but a virtual channel which is used to make the communication happening inside it secure. Right. So that is the main concern. That is the main motive of this secure shell. It is more powerful than FTP, as we had seen yesterday that FTP makes use of port number 21. In some cases, it might make use of port number 22 if it wants the communication to be secured. What exactly Secure Shell does is it makes use of port number 22 for remote file transferring from one place to the other place, okay, with the help of a secure shell environment. It is mostly used for remote execution. The main difference I told you yesterday between SSL and SSH is Secure Shell is mostly used for transferring files, okay, from one location to the other location, whereas a secure socket layer is basically used to encrypt the entire session. Okay. For example, you're using a particular web browser, you want to access a particular site, you are going to make use of SSL and not SSH. SSH is basically used in those cases where we want to transfer files from one particular location to the other location. For example, you want your files to be transferred from your machine to your web server's machine, right? In such a case, we are going to make use of SSH. Okay, its practical implementation is in the form of PuTTY and SFTP. Okay, PuTTY is one of the software, and next is SFTP or FTPS. This is basically secured FTP, using which you can transfer your files from one location to the other location. Clear with this? This is just the introduction of what SSH is. It makes use of port number 22, that is FTPS. This is how the overall architecture of SSH looks like. Just go through it once and let me know if you're understanding this particular diagram. Okay. So this is the diagram for secure shell. There's a client, there is a web server. You want your data to be transferred to the web server through a secure channel, which is called as secure shell or a tunnel. Okay. Obviously, this has to go through the internet, and the internet is obviously not secure. So it's our responsibility to secure the communication, okay, with the help of providing a virtual tunnel, which is called as secure shell. So we basically have to construct this secure shell. Okay. So now this is nothing but a tunnel, which is called as SSH tunnel. Over here, it's mentioned as SSH tunnel. This is securing the end-to-end communication. That is, the client is sending some data from this end, and the server will receive the data from this end. So the end-to-end protection, as it's very popular nowadays, WhatsApp is using end-to-end encryption. It is using 256-bit AES. Similar sort of a concept. End-to-end encryption using a tunnel, virtual tunnel, is called as SSH or a secure shell. Now let's start with the technicalities of what SSH is. It is again having very detailed steps. I have simply highlighted the number of steps over here, and then we will go in detail what exactly these steps are. Okay, so this is how SSH works. The very first step is the client initiates the connection to the server. Okay, what does the client do is the client will initiate the connection to the server by sending a request to the TCP port of the SSH server. All the communication has to go through TCP, because if we want the communication to be secure, we can't make use of UDP. Correct? If you remember connection less and connection oriented protocols. TCP is connection oriented protocol, whereas UDP is connection less, as you all know. इतना पता होगा आप लोगों को, CN में पढ़ा आप लोगों ने, right? So basically UDP is much more secured as compared to, sorry, TCP is much more secured as compared to UDP. That is why the client will make use of TCP protocol. What the client will do is the client will initiate the connection by sending a request to the TCP port of the SSH server. कि मुझे so and so request चाहिए, so and so file मुझे transfer करना है, kindly allow me to do so. This is the very first step. Clear with this? The second step is the server will convey its SSH version to the client. As if you remember in the previous case in secure socket layer, what happened? The very first message that was sent was in phase one. They actually sent the SSL version. Client used to send the highest SSL version supported by it, and server used to send the lowest SSL version supported by it. याद आ रहा है? Do you remember? The similar kind of a thing is happening over here. What is happening? The server will convey its secure shell protocol version to the client. Now, what happens? The client will check whether that version is compatible or not. If the client supports that particular version, then if they are compatible, the connection proceeds. Clear with this? Any issues till step number 3? If you're having any issues, kindly let me know. So basically, the client and the server has to decide which version is compatible. If at all they feel that no version is compatible enough, then what they can do is the communication will either end over there, or they have to make sure that they have a version which is compatible with each of them. Otherwise, they can't proceed ahead with the communication. Clear with this? So till now, step 3 is done, I guess. Step number 4 is all about the very first communication by the server. After coming to a conclusion that so and so communication is compatible, the server will send few details. What are those details? The server sends the following data to the client. These are the following things. The server will first of all send a host key. Host is nothing but the actual resource provider. Okay, it can be a server, it can be a file server, whatever. Actual resource manager or a resource allocator. That is nothing but the host. So the server will first of all send the host key. Now, in some situation, it might happen that the server itself is the host. So in that case, the host key and the server key will be same. Clear? So for example, the server is controlling 3 or 4 machines. Okay, so one of the machine is a host, right? So the server will send the key of that host as the first message. The second message will be the key of the server itself. Server host keys. host key and server key, right? Followed by list of supported algorithms. If you try to compare this with SSL, again, there also we used to send the list of algorithms. Okay, the client used to send the list of algorithms. Over here, the server is sending the list of algorithms, supported algorithms. याद आ रहा है सबको? Try to compare it with SSL. In SSL phase 1, the client used to send the list of supported algorithms, and the server used to select one of those algorithms, if you remember. Over here, what is happening? The server is sending a list of supported algorithms. For example, the algorithms can be encryption algorithms, they can be compression, authentication, etc. Okay, so these algorithms are sent to the client along with last bit of information, that is sequence of 8 random bytes. Do you remember we had done in secure socket layer also? We used to we actually made use of some random bits of information. Why so? It was just made to ensure that the session cannot be replayed or repeated once again by any attacker. So any doubt so far till point number 4? We are going step by step. Okay, we have first of all seen that the client initiates the connection with the server. The server will convey its secure shell version to the client. If the client is compatible with the server's version, they can proceed with the communication. And in step number 4, we have seen that these are the information bits that the server will send to the client, right? So that is nothing but the host key, the server key, list of supported algorithms, and sequence of 8 random bytes. Clear with this? Any issues so far till step number 4? Kindly let me know. If you are getting confused, kindly let me know, because अभी जो process चालू होगा वो और confusing होगा. So far, if it is clear, kindly let me know. Okay, okay, thank you so much. So we can proceed ahead. In step number 5, what exactly happens is now the client has received all these 4 informations, that is host key, server key, list of algorithms, and sequence of 8 random bytes. Now what the client does is the client checks the host key with a known database. Now what happens is, for example, I know that there are 5 resources or there are 5 hosts. Okay, and I have received the host key from the server. So what I will do is I will compare that host key with this database. If it matches with any of these 5 values, then I will come to know that my so and so host is active. That is not an imposter trying to hack my session, right? Whatever I'm trying to say, just kindly have a look into it. The client will check the host key which was being sent by the server and compares it with a known database to actually verify whether the server is telling the truth or not. Why so? Because it may happen that the server has already been hacked by an attacker, and the server will send a host key which doesn't even belong to this known database. Then what will happen? The client can make sure whether the server is telling the truth or not. If the client receives a host key which is not present in any of these 5 resources, for example, then the client will come to a conclusion that either the server is telling lies or the server has been attacked by an attacker. Clear with this? So basically, this is a step where the client is making sure that the server is telling the truth. Right? Clear so far till step number 5? So both ways authentication has to be done. The client has to be authenticated to the server, and the server also needs to be authenticated to the client. The same thing happened in SSL also. The same thing happened in Kerberos also. The same thing is going to happen here also. All of these may be similar in architecture or maybe similar in construction, but all of them have predefined specific tasks to do. Kerberos was totally used for authentication. It is nothing but an authentication protocol. Needham Schroeder is again an authentication protocol. Secure socket layer is used to encrypt your entire internet session, whereas SSH is basically used to encrypt or basically used to secure your file transfer process. Clear with this? Any doubts so far? I have talked about all the various versions of these protocols. Okay, kindly let me know. Okay. Okay, thank you so much. So let's move ahead with step number 6. Now, step number 6 is nothing but we have so far got the host key, the server key, the sequence of 8 random bytes, and list of supported algorithms. Now the client is sure that the server is correct, the server is not fake, or the host keys being sent by the server actually belong to the database. Clear? So now the client will generate a session ID. Now, this session ID will be used throughout the session. This session ID cannot be tampered with. If at some point of time the server or the client receives a session ID which is different from this value, then it may be assumed that either any attack has happened, either the session ID has been tampered with, or some sort of replay attack is happening. We'll see in detail what exactly is a replay attack. You already know what exactly is a replay attack. You might have seen it in CSS. So the same thing is being applied over here. The client first of all generates a random session ID, double encrypts it using the host key and the server key. This is very important. The most important step in this phase. Kindly go through it once again. The client generates a random session ID, okay, and it double encrypts it. First of all, it encrypts it with the host key, and this entire message will again be encrypted with the server's key. Getting an idea what I'm trying to say? That's why I've drawn this little piece of diagram over here. First of all, the client will generate a session ID. That session ID will be encrypted using the host key, which the client has already received in step number 4. That envelope or that message will be encrypted once again with the server key. Now, this order can change. Huh? Session ID can be encrypted with server key and then it can be encrypted with the host key. The order can change. As we know, these are distributive, associative, commutative. The same theory applies over here, right? So the session ID is basically double encrypted using the host key and the server's key. Now, what is the intention of doing this? Can anyone tell me? Why are we encrypting the message using the contents received by the server? Step number 4, 5, and 6, combine them and try to give this answer. Let's go step by step. The client generates a random session ID, double encrypts it using the host key and the server key. What is the intention of doing this? Why are we adding extra bit of complexity if you feel so? Kindly let me know.
तो सर मतलब अगर कोई बीच में से अटैक करने जाएगा तो मतलब जो सर्वर की है वो सर्वर के पास मतलब उसके लॉग में रहेगा तो उसके वजह से वो क्रॉस वैलिडेट हो सकता है.
As in, अगर सपोज मैं अटैक कर रहा हूँ,
हाँ
do
तो
I have
बेसिकली आपके पास मतलब मैसेज अलग होगा सर्वर के अलग होगा तो उनका जो एक रैंडम सेशन आईडी बनेगा वो भी चीज अलग ही होगी तो मतलब जो सर्वर के पास रहेगा वो उसके साथ ऑथेंटिकेट कर सकता है कि हाँ ये मेरे लॉग में से ये की यूज हुआ है मे बी.
correct? So basically, partially correct. I can say is, sir, if any attack happens, the attacker first of all won't have access to the server key and the host key. So obviously गलत ही भेजेगा वो because उसके पास access होगा ही नहीं server key और host key का. So what exactly is happening is, whenever the client generates this random session ID, obviously only the client knows about it. Any attacker doesn't have any little bit of clue about the session ID because it's totally random. Okay, first thing. Second thing, it is being encrypted with the host key and the server key. Now, we know that the server has sent this information only to the client, right? Only to the genuine client or authentic client. So, whenever the server receives this information, it compares this information with the one it has already sent. Okay, obviously अगर दोनों मैच होंगे तो ही वो वेरीफाई होगा, अदरवाइज वेरीफाई नहीं होगा. दिस पार्ट वाज करेक्ट, explained by Gunjan. So what exactly happens is the client can also get authenticated to the server using this particular step. Yes or no? Because only the client has got the information about the host key and the server key. Nobody else other than the client has got information to the host key and server key. Because in step number 4, only the client has been sent so and so values and nobody else is having that information. Right? So in step number 6, the client itself is getting authenticated to the server. Clear? So in step number 5, client was authenticating the server. In step number 6, the server can authenticate the client using this step. Clear with this? So it's again a very technical topic. So we have to go step by step and slowly. Clear with this? Okay. Now in step number 7, what exactly is happening is already the session ID is being created. So client will send this session ID which it has created along with the accepted algorithms. I have combined step 6 and 7 together. So what exactly happens is the algorithms which it supports will be sent along with the packet which has been generated in step number 6. Clear with this? So now what happens is the server will obviously be able to decrypt the encrypted session key because the server itself is having the session key, right? Sorry, the server's key. So the server can decrypt this message because it has got access to both the server's key as well as the host key, right? So the server will be able to decrypt that message and the session ID can be decrypted back. So as a result, now the server will also have access to the wherever I have written session ID and session key both are same. Huh? So don't get confused. Session key and session ID both are same thing. So the server is now in a position to decrypt the session ID or the session key from that message. So अभी दोनों के पास same चीज हो गई है. Both the server as well as the client has got access to the session key. Now what happens is, now tell me यहाँ तक सबका clear है? Then only I will move ahead till point number 8. Point number 9 is all about double authentication or double verification. I'm going to go in detail into it. But first of all, tell me if this much is clear or not. Till point number 8. Okay, thank you so much. So let's move ahead with point number 9. What exactly happens in point number 9 is the server sends a confirmation message. This is nothing but a message that by so and so information मुझे मिल चुका है. I have got this session ID. So kindly accept this confirmation from my side. So what is happening is now the client will come to know that whatever message उसने भेजा था that has been received properly by the server. It is nothing but like an acknowledgement that the server has received the message from the client and it has been acknowledged by sending a confirmation message which is encrypted by the session key. Why it is being done? Kindly let me know. For example, this is a text. It can be any bit. It can be a simple plain text where I write confirm. Okay. And this is being encrypted with the key that is session key. Now tell me session key or session ID. Now tell me what is the significance of this step? Why is this step being done? Obviously, acknowledgement जा रहा है वो बहुत अच्छी बात है. What apart from that? Let me know. Acknowledgement to जा रहा है, no issues with that. But what else? The server is sending a confirmation message encrypted using the session key. What is the significance of this step?
क्योंकि सर वो की तो सिर्फ क्लाइंट के पास ही रहेगा, बीच के मिडलमैन या अटैकर के पास नहीं रहेगा, तो सिर्फ क्लाइंट ही उसको मतलब समझ सकता है कि भाई कंफर्मेशन आया है सच्ची में.
नहीं वो तो ठीक है, बट मैसेज आ कहां से रहा है वो इंपॉर्टेंट है ना. कौन भेज रहा है वो भी तो देखो. ये only client and server. I agree, 90% correct. Only client and server has got access to server session key. Okay, session ID. Okay, so no one outside can have it. Rishikesh has written it. Okay, correct. So basically, what exactly we are trying to do is the message has been sent by the server, right? The confirm message is coming from the server. If the session ID matches, then only the server will be able to send it, right? Because session ID अभी दोनों के पास है, client के पास भी है, server के पास भी है. So the server only can send it because now it has got access to the session ID. So first thing first is whenever this message is received by the client will first of all check whether this session ID is correct or not. If at all this session ID is correct, then only the authenticity of the server can be verified. So we are doing step-by-step verification, not only once, we are doing it once, twice, thrice. आगे और देखोगे और verifications होने वाले हैं. So it is nothing but we are doing 2-level, 3-level security similar to your OTP. Or we can say that two-step authentication. This is the basis or fundamental of a two-step authentication. समझा अभी सबको why? What exactly is the step number 9? Over here we have done the confirmation. Over here we have done the verification of the server twice. एक बार हम लोग ऊपर भी देख चुके हैं in step number 5, and over here once again we are confirming whether the server is correct or not. मतलब trust है ही नहीं किसी पे. Don't trust anyone whenever you are accessing the internet. Okay. So this is the main funda. This is the thumb rule. There should not be any blind trust on anyone. You have to verify at each step whether that person is telling the truth or not. At the end of the day, you are dealing with lots of huge amount of data, money, finance, everything is involved over the internet. So you can't blindly trust anyone on the internet without confirmation, right? So the same funda applies over here. And likewise, in step number 9, the client is authenticating the server. Similarly, the client also sends the same message back or the acknowledgement of the previous step back to the server to authenticate itself once again. So here we have authenticated the server and the client two times. This is what we call as two-step authentication. Clear with this? Till step number 10 we have covered. Okay. Kindly let me know if you are clear with this particular concept. Okay, thank you so much. Till step number 10. Okay, thanks. So I guess we can move ahead and complete the remaining steps. We are having 4 steps more. So step number 11, let me zoom it up. Step number 11 is nothing but so far the connection has been established. Okay, this is nothing but you can correlate this with the first phase of your SSL. So the connection, SSL handshaking. So the connection has been established. Now what happens is the server will generate a 256-bit random challenge. Okay. At any point of time, the server may make use of such things, okay, out of nowhere. The server can create or generate a 256-bit random challenge, encrypt it using the client's public key. Obviously, the public key is available to all, and send it to the client. Now, this is again out of nowhere. The server randomly generates a 256-bit random challenge and encrypts it using the client's public key and sends it to the client. Now, this step happens once the communication connection establishment has completed. Why it is being done? Just to check whether the client is active, whether the client is actually present inside the network or not. Why so? Because whenever the server encrypts any message, whatever it may be a 256-bit value or it may be a 1000-bit value, whatever it is, whatever it is, if the server is encrypting such a message using the client's public key and sends it to the client, it just wants to make sure whether the client is active, whether the client is actually taking part in the communication or not. Why? Because the client only will be able to decrypt it using his or her private key. As we all know, if we encrypt with the public key, we can decrypt it using the private key. Correct? There is a resemblance, there is what we can say a semblance or a correlation between the private key and the public key. That is why if I encrypt with a public key, I can decrypt with a private key. On the other hand, if I encrypt with a private key, I can decrypt it with the public key. So the same thing is happening over here. The server is generating this message and sending it to the client using the client's public key. The client only will be able to decrypt it. If the client is able to decrypt it, the server will come to know that the client is still active. Because कभी कभी क्लास में we ask questions just to check whether people are attentive or not, right? That is the same purpose of this entire step. If the client is attentive, if the client is active, the client will decrypt the message being sent by the server and it will generate a hash with the session key. Here it gets complex. Here where it gets complex, why? Because till step number 11, everything is smooth enough. In step number 12, what exactly happens is the client decrypts the message being sent by the server in step number 11 and generates a hash of that message with the session key. Now, again, why we are doing this, we just want to make sure that the integrity is maintained. Why so? Because if the server is sending some 256-bit random challenge to the client is decrypting the message, and the client is now taking a hash of that message with the session key. We know how to take hashes with keys. That is nothing but known as MAC or HMAC, hash-based message authentication code. We have already seen it. If you want, you can just revise it once again from your CSS syllabus what exactly is HMAC, what exactly is MAC. So it's in simple terms, we can say that creating a hash with the help of a key is known as MAC or HMAC. Clear? Now, kindly tell me why we are doing so. I have already mentioned it over here. Let me know what is the importance of this step. This is not related to authentication. We are doing this to make sure that fill in the blanks. Dash dash. Kindly let me know what exactly is the significance of this step. Others also kindly take part in this Q&A. I don't want only few of you to give me the answers. Kindly take part actively. It's not about only the attendance. Okay. Okay, let me know. You can make use of the chat box also if you're not comfortable speaking into the mic. No issues with that. But let me know that you are awake. Let me know that the message is being received by you and you are able to decrypt it back. Okay, so try to give me the answers. Come on, quick. Otherwise, वही लोग वापस आंसर देंगे जो हर बार देते हैं. Avoid session hijacking. Okay, I can assure that yeah, it's one of the correct answers. Avoid session hijacking or basically avoid replaying, because if we are trying to replay it, the hash values won't match. Correct answer, Rishikesh. Kajal, correct answer. It is just basically to check whether the client is active or not. Attentive तो मैंने example दिया था class के हिसाब से. Basically, the client is active or not, the client is present inside the network or not. We can check it using this method. Okay. Second, technically answered correctly by Rishikesh, to avoid replaying, to avoid session hijacking. Okay, because session hijack can take place if we get hold of the session key. So if we don't have the session key, session hijacking cannot take place. Okay. Any more answers? I've got two answers so far. Kindly go through the steps once again. Point number 12 I'm talking about, to check whether the client is present in the network or not, whether the client is able to decrypt the messages properly or not. Okay, only two of you are attentive in the class. I can come to a conclusion. Rest of you are not answering. So what to do? Personally पूछना पड़ेगा मुझे एक एक को. Okay, so who is going to answer this? Or let me know. I will take out call out names. एक आंसर दे दो फटाक से जल्दी से, then I can move ahead. Yeah. Okay. अभी सब यही आंसर देंगे ना. Mine was the same as Rishikesh. Okay. What else? Anything else apart from this? What about others? Are you only sitting for attendance? No, na. So then give me the answer. Fatak se jaldi. Yeah, it ensures that the messages sent are received in a complete and unmodified form. Correct. Integrity. Basically, I was looking at integrity to maintain the session privacy. No, to maintain the second. We can say to maintain the session's integrity. Kannan. Because privacy has already been covered in the previous steps. Whenever we had checked for authentication, we came to a conclusion that privacy is maintained. Now, step number 11, 12 onwards, we are looking at towards the integrity aspect of the goals of security. We already know now there are three goals: confidentiality, integrity, and availability. Right? So we have already made sure that confidentiality is secured. Now we are moving towards integrity. Right? At some point of time, we may not be able to make sure that availability is maintained, but we obviously go for these two every single time: confidentiality and integrity. So now we are looking towards the integrity of the data. We just want to make sure that the data is not tampered with. Step number 10 तक हम लोगों ने already देख लिया कि how we can create a connection. Step number 11 onwards, now we are moving towards the integrity of data. That is, once the communication has begun, we want to make sure that the data is not tampered with, right? So that is the main answer I was looking for: integrity. So now we can move ahead with step number 13. This is the last step. Server also generates the hash of the challenge. Whatever message it receives, first of all, check with the answer. In step number 11, the server is sending this challenge bit, right? Random challenge. At that point, the client will receive this challenge, create a hash of that challenge, and send it back to the server. Now, what the server will do is, server will again create a hash of the same message it had sent. just for the sake of integrity checking. The server will again create the challenge and it will compare with the challenge that it has received in step number 12. If both of them match, then only we can come to a conclusion that the session is authenticated as well as the integrity is maintained. Clear with this? Any doubts, any issues with the 14 steps we have covered so far? Kindly let me know step by step. If you want, I can just quickly revise all these steps once again so that it goes into a head for a long and stays for a long amount of time. That is the whole intention of going with the whiteboard sort of patterns, or otherwise I could have used the PPTs also. But I just want the session to be interactive enough, so that's why I'm sticking with this whiteboard. This stays in your mind for a very long time, if I if I am not wrong. Okay, so let me quickly go through these steps once again. The very first step is the client initiates the connection with the server. The server will convey whatever SSH version it has to the client. Correct. Next step is if the server has got the compatible SSH versions, the connection can proceed ahead. Otherwise, there will be some sort of issues with uh, with the SSH. If there is an issue or a delay from client's side, what will be the protocol then? Delay as in there won't be any delay. It will basically it will be a timeout, and after the timeout, the server will again send the message once again. As you have seen in computer networks, there is a retransmission window. If you remember, the if at the end of the retransmission window the client is not able to reply back, the same message will be sent again. But this has a drawback because as the messages may keep on flooding the entire network, and as a result, it may cause some the buffers to overflow, right? So what happens? There has to be some sort of mechanism that if a session has expired, a new session should replace the existing sessions. Yeah, very well said by Rishikesh. Once a session is expired, again the entire process will begin, starting from the session ID. That is from step number 6. If the client is not able to answer the server within a particular retransmission window time, it will be assumed that the client is dead and the step number 6 has to begin from scratch. The entire process will be beginning from step number 6 once again. Okay, so just to avoid any retransmission or any attack from malicious actors, this particular step will again fall back and it will start from step number 6. Okay, so I hope that was answered properly. So let's go back to once again step number 3. If it is compatible, connection proceeds. Step number 4 is the server will send the colon to the client. As you all know, 4 values are being sent: host key, server key, list of algorithms, and sequence of 8 random bytes. Step number 5 is all about the client checks whether the host actually is a part of the database or not. Clear. Step number 6 is it generates a random session ID just to cross check whether the host and server keys actually belonging to the server or not. Step number 7 is the client sends the message to the server to check the server's authenticity. Step number 8 is all about the server will decrypt the message and uh, pull out the session ID from that message. Once the server has got the session ID, the server will send a confirmation message or acknowledgement message to the client, encrypting the message with the session ID. Obviously, we have done this. The same thing will be done by the client and the connection will be established till point number 10. Point number 11 onwards, we are checking the integrity of the connection. The connection has been established. Now the integrity has to be checked. So the server generates a 256-bit random challenge, encrypts it using the client's public key, and sends it to the client. Only the client will be able to decrypt it. Once the client decrypts it with the private key of the client, it generates a hash with the session key and sends it to the server. The server also will do the same process. The server will take the hash of the challenge with which it had sent in step number 11 and take the hash with the same session key. Finally, if both the hash values are matching up, then only we can come to a conclusion that the entire session is authentic and this entire process is complete. So happy file transferring. This is what happens when you use secure file transfer or secure FTP over SSH, right? So the entire process takes hardly 1 or 2 seconds. and at the back end, the entire process begins. Clear with this, so we have completed a very important question. It comes for 10 marks. What exactly is a secure shell? So you have to write this, you have to draw this diagram, you have to give the intro. I have already given you the uh, structure how you need to answer this question. First of all, start with what exactly is SSH, draw the diagram of a normal SSH structure, and then write down how SSH works. In between, wherever possible, try to uh, draw some diagrams. For example, over here for step number 7 and 8, I have drawn a diagram. Wherever there is some sort of encryption happening, decryption happening, try to illustrate it with the help of diagrams. Okay, so it leaves a good impression whenever you are writing in the exam. Clear with this? So any doubts with SSH? It's actually a tricky concept. I'm just trying to simplify it using diagrams and other techniques. So let me know if you have got the understanding of what exactly is SSH. Then I can move ahead with the next topics. So next, let's move ahead with the next topic for the day. That is how you can secure yourself over the internet. What are the various measures you can take to ensure that your privacy is maintained? Again, I'll start with this topic and let's see if we are able to continue with the next topics or not. I don't think so. We are going to be able to complete it, but let's start with this topic. As we have these three topics for today, let me show you. We have covered what exactly is secure shell. This comes for 10 marks. Okay, it can be either asked as a short note for 10 marks in question number 6 or 7. Okay, or it can be asked for a 5 marks question also. It depends. The next topic is privacy on web. It's basically a very short answer. So it comes for 5 marks. Web browser attacks again comes for 10 marks. So next, move on towards privacy on web. You are all aware of it. How to ensure your privacy? I will just highlight the very few steps or the things which you should make sure to ensure your privacy. Okay, so these are not technical enough. These are simple uh, things you should make sure to ensure your privacy. So what exactly, why exactly we are studying this? Whenever we are making use of the internet, the web browsing habits are tracked via cookies. Yes, so whatever we are communicating on the internet or the World Wide Web, all those habits or all our browsing habits are being tracked via cookies. Even search engines routinely change their privacy policies, and there are always challenges being posed to the web security or web privacy. What exactly I'm saying is the web browsers or the search engines routinely change their privacy policies. Basically, what they do, they will update their privacy policy and they will send it to you either via email or as a pop-up. What exactly happens is if you are not attentive enough, you may click on it, proceed okay, and then you move ahead. But what exactly happening is whenever you're clicking that OK button or submit button, you are agreeing to their updated policy. As a result, what happens whenever you visit that particular website or whenever you make use of that search engine already has your acknowledged policy document with them. So at any point of time, you cannot blame that organization because you yourself have agreed to their steps or their license agreements. So you have to be careful enough, you have to be attentive enough, read the end user license agreement, which is also in short called as EULA, end user license agreements. Read them properly, read them thoroughly, and then only accept it or admit it. So I'm going to focus, I'm going to highlight few points. Don't follow these steps every single time, but it's always better to follow these steps to make sure your internet browsing experience is well enough. It's not bitter. Okay. Very first thing is clean up your search history. Okay, this is very crucial. Whatever you whatever you search, okay, whatever you search. I'm not going into much details of what exactly you're searching. I'm just saying whatever you're searching, just clean up your search history whenever you're quitting that particular session. Whenever you're closing that browser, make a habit of cleaning your search history. You can automatically put a checkbox that whenever I exit, delete my cookies or delete my search history. This is a very good habit because your IP addresses won't be tracked. Okay, I'm just giving an example. If you're watching a YouTube video, okay, and you delete your search history, YouTube won't be having your search details with them because you have deleted your IP address, you have deleted your searching history. The next time, whenever you log into your YouTube, it might be considered as a totally new session because YouTube will not be having your search history with them, right? I'm just giving an example of YouTube. This applies to every single organization. So if you want your search histories, if you want your browsing habits not to be tracked by the end user, by the third party, then you should obviously every single time clean up your search history. This is just for our protection, not for carrying out any ill activities, right? So I'm just telling you about the various ways by which you can protect yourself. Okay, you are not doing any harm to the organization such as YouTube. You are just protecting yourself from any harm done by any third party. Okay, next up, secure your web browser. Your web browser, as explained earlier, is the main program you make use to go online. So just make sure that your web browser is secure enough. Continuously keep it updated. Okay, turn the auto updates on for your web browser. Don't trust any third party web browsers, as I have always explained, always talked about in the past lectures also. Have two or three browsers at the max, but keep them updated every single time. Okay, so that is how you can secure your web browser. Next up, log out of search engines and websites after your task is finished. We always have a tendency to keep ourselves logged in, but just make sure to log out of those search engines or web browsers, or for example Facebook. Don't keep your Facebook or Twitter account logged in for a long time. If you're accessing the same account n number of times, no issues. It will take hardly 1 or 2 minutes to log into that session the next morning. So just make a habit of logging out of your accounts before going to sleep or whenever you're not using it. It basically protects your session. It basically protects your account. Nowadays, we always come to know that so and so person's Twitter account has been hacked. Twitter is very vulnerable as compared to Facebook. So if you're having Twitter accounts, kindly log out your sessions, kindly clear your cookies, kindly clear your sessions, and then go to sleep. Okay, it hardly takes 2 minutes to log in once again, so it's not a big deal. Okay. Next up, don't give out too much information. I have focused on this particular task, particular point, n number of times. Don't give out too much information in public domain. I'm visiting so and so. Don't allow check-ins publicly. You reveal your entire life to the people who are always at that जो basically they are lookout of getting information out of your activities. We can pause it, no issues with that, but still Google will have access to your search history whenever you unpause it. They will basically be tracking it. They won't show it to you, but they will be tracking it. So the best way is to just clean your cookies, clean your browsers every single time. That is the most effective way I have found out. Okay. Next up is don't give out too much information. There is no basically there is no need of posting too much information. Only if you want your life to be presented in public domain, then only go for revealing too much information. Otherwise, keep it as it is. Don't put out check-ins every single time you are going to so and so. Going to office selfie, so and so. Don't try and reveal your entire life to every single person. Obviously, social media is used for sharing our day-to-day activities, but keep it limited because not only you are sharing your information with your friends, you are also sharing your information with the attackers also, or the prospect attackers. So try to keep it limited. Okay. Next up, watch what you are downloading. Very crucial. Don't download from any third party websites. Always go for secure websites and then only download things. I'm not going into detail. What Simply watch what you are downloading. That's it. It may have some viruses inside, so kindly scan the application before installing, and so and so. Okay, let's continue. Point number six, using services without reading their terms and conditions. This is how I introduce this particular topic. You should always read the end user license agreement before clicking next, next, next. Same thing happens with installation of new softwares. We click on next, next, next without even looking into it. Sagar, we can obviously download first and then scan it before clicking it. मैंने पहले भी बताया था, you can use the website virustotal.com. You can download a file but don't execute it. Before execution, scan it properly using a particular website, for example, Virus Total, and if it comes out to be healthy, then only install it. Before downloading it, it is really difficult, I guess. If I have said so, I take my words back because before downloading, you can't scan a particular application. That can be done only from the web browsers of web servers end. Whenever you own a particular web server, then only you can check the file at the point of uploading. But you can't scan a file without downloading, right? If you come to know anything of that sort, kindly let me know. I might not be having information about that. Kindly let me know, and others also, if you get to know about any application or any website which scans your software before even downloading. That would be really helpful for everyone else. Correct. Windows Defender will remove it as soon as you try to execute it, but at some point of time, even Windows Defender fails because it might be a polymorphic virus. It might change its signatures each and every time. So it's always better, and on the safer side, you can scan the particular file before installing it. It's always better. Okay. So next up is guard your private information. Obviously, you should guard your private information. You should not reveal your phone numbers. You should not reveal your work email IDs. Okay. Next up, use caution on social media sites. I've already focused on it. Delete the cookies. Sorry, it is browser. Delete the cookies at browser exit. Whenever you're exiting the browser, make it a point that you should delete your cookies. Okay. Then protect your computer and mobile devices. You can make use of antiviruses. Windows Defender is by default using it, making use of it. You can make use of paid antiviruses. Uh, Norton is a good one. McAfee is a good one. So if you want to protect your machines thoroughly, make a habit. Don't download free antiviruses. They may have viruses inside them as well. So don't go for them. If you are actually thinking of protecting your system, go with a paid software, paid antivirus. Quick Heal is also a good one. Yeah, correct. AVG, Avast, Quick Heal, McAfee, Norton. These are uh, the better softwares, better antiviruses. Keep your Windows update on, automatic updates on. Keep your browsers automatic update on. Let it update on its own. It will basically save your time and it will basically save your files as well. So this was all about today's lecture. If you're having any doubts, you can discuss. If you want to discuss anything, you can discuss with me or with the others. In the next lecture, we are going to focus on the various web browser attacks. So I hope this lecture was informative enough. Kindly let me know if you have any doubts.